Hey, good morning, and welcome to the Level Up Hour, where we talk about all things containers, Kubernetes, and OpenShift. And so I am joined today by my co-host, Mr. Scott McBrien. Scott, how are you doing?
Doing great, Randy. Looking forward to talking to our guests this morning.
Indeed. So, we have a really interesting show today because it starts with a premise. How can we maintain trust in the cloud and ensure that we're building secure systems, which I think is an open question, but maybe not completely open. We're going to talk a little bit about the Keylime project, and perhaps before we dig into the details of Keylime, maybe help understand what some of the main issues are. And so today, we are joined by Lucy Kerner, who is our Red Hat's Director of Security, Global Strategy and Evangelism, Michael Peters, Principal Emerging Technologies Developer, and Lily Sturmann, who is our Senior Software Engineer. So greetings all. Thank you for joining us today.
Hey, everyone.
So before we get started, I just want to remind everybody, please like, subscribe, and share to let everyone know we're on the air. And let's get into it. So Lucy, how can we actually make sure that we're building secure systems and applications in the cloud? Because there's an implied trust there. We're going into the great beyond, and how do we do that?
Right, and it's not a simple answer, right? It's not like I can say security is not like, oh, I buy this one product or I do this one thing or and I have this silver bullet solution kind of thing, right? It's about tackling it across people, process, technology. It's about shared responsibility with the public cloud providers and yourself. It's using a layered security defense strategy. Again, there's no such thing as 100% security. There is always going to be a trade-off. You can't fix everything. You're not going to have enough people, time, resources, right? That's always going to be a challenge. For example, have a strategy for data security across the hybrid cloud. Whether you're talking about data in the cloud or on premise, the CIA triad, confidentiality, integrity, availability, it's still true, right? You still need to know, is the data appropriately accessible when needed? Is it who has access to the data? Making sure that you tackle the data security from not only the cloud platform but the cloud image, the cloud hosts, right? The growth of workloads in the cloud it's growing all the time, right? So in developers, you're seeing them have much more control over the application pipeline and lifecycle. They're downloading things directly off the internet, whether it's open source packages or libraries, that kind of thing. So you're seeing these increased breaches in software supply chain, like the SolarWinds breach. So you want to have a strategy for software supply chain security. You want to make sure that you have that consistent, repeatable framework, like an SDLC in-house, to develop applications not only quickly but also securely and built in early in that pipeline. When you're consuming open source technologies, you want to, if you're doing it yourself, right? If you're consuming it directly yourself and not using enterprise open source from vendors such as ourselves, you want to create your own product security team. Find out new vulnerabilities that are all in all the open source packages you're using. First of all, but first you have to know all of the open source technologies and packages you're using. Assess the security impact of the software that you have. Of course, creating or getting the security fixes, and not only getting it, but also doing the isolating and doing backported fixes as well. As I mentioned earlier, it's not just a technology problem. There's a huge people and process aspects to it as well. You see a lot of research and survey out there around there's just not enough security resources out there, and people there's not enough security people out there, right? So you can't just throw bodies at the problem. That's not going to be sufficient, right? You want to, especially
there's not enough bodies available.
Right, there's not enough. And also the good ones, they usually there's a very short lifespan of CISOs, like they don't stick around forever, right? Like a lot of them leave within a year, maybe 2 years, right? So, and goods really, security people are in high demand, especially, anyone who's doing cloud security. So that's another challenge, right? So, and especially with containers and Kubernetes and these newer cloud technologies, you really need to have that cross collaboration. You can't do silos, right? And you can't have silos, and that's one of the huge challenges and why that these technologies are not getting adopted very quickly, right? Because you have you need to have app dev, operations, security, and compliance, all of those teams working, understanding how you tackle security differently in this new world. The tools may be different, the way you think about security is different, and so you want to make sure all of these teams are educated. You don't want to be thinking about doing security you can't just like throw it over the wall anymore. Doing last minute 11th hour panic like pen testing and security scans, those kinds of things. Those are highly prone to human error, right? So you don't want to, and misconfigurations, those kinds of things, which are one of the top reasons for the security breaches out there. Make it a team sport, right? So that's another big one. Go ahead. Sorry.
So Lucy, you started talking about some of the challenges and like technologies and a variety of other kind of top level issues within the security space right now. But what are the biggest hurdles in the IT space in regards to containers and Kubernetes, in your opinion?
So I think one of them is, as I said, a lot of teams are not used to this new way of thinking. So I'll give you an example. I was at a customer about 2 years, before COVID, right? And I was sitting with the security team, and they were trying to manage their containers and Kubernetes environment. And they were trying to use some of their legacy tooling, because that's what they're familiar with, right? They were tracking IP addresses. They were trying to track IP addresses of all of these containers. And they were like, I can't keep track of them. It's crashing all over the place, my tool, right? So they didn't realize that, this is a immutable environment. This is an environment where containers are coming up and down and coming up and down. You can't be tracking it with things like, Nagios or, things like the standard monitoring tools that they're used to. But that's what they're familiar with. And not only are they familiar with it, they're comfortable with it. They've built their career around these tools. So it's very hard for them to kind of say, oh, well, no, you have to use this like tool you've never heard of, this, that kind of thing. And also it is this different way of thinking, right? And then, and it also like they'll be saying things like, well, I need to be installing my antivirus or my third-party scanner on, Core OS, like an immutable OS. They're not used to, well, that's not what you're supposed to be doing, right? So this kind of education session, and then not only that, but the compliance teams as well. They are, if you look at the auditor, a lot of times it's about the auditors are very used to this defend the castle perimeter security type of approach, where it's not, you're not used to this kind of immutable infrastructure. So a lot of the compliance rules out there, like the security controls and the security policies, are built or written for this defend the castle perimeter security type of approach, where you're not dealing with this kind of immutable infrastructure. So that's another challenge, that it's a lot of this, security teams talking to the compliance teams and the auditors to try to make them understand that, yes, third party in doing antivirus or agents doesn't make sense in this environment, or those kinds of things is another big challenge as well. And also for the containers and Kubernetes side, it's another layer of defense that teams have to take. Everything from using trusted content, that's a big challenge. Like the developers just downloading stuff from the internet, not using things like what we offer, for example, like UBI, container images that we've put in Red Hat Container Catalog, right. Those kinds of operator hub, right? They're just also using an enterprise registry. Those kinds of practices should be in place to control the application security, protect the platform itself, and then also detecting and responding at the runtime. And then so protecting the platform itself. If you're not going to use, let's say, OpenShift, then you're going to have to figure out a strategy to how am I going to do all of the deployment things, right? Like, if I'm not using operators and enabling RBAC by default, or, protecting the platform data, which we do by default in OpenShift, all the policy-based deployments we're doing with like ACS, Advanced Cluster Manager, Advanced Cluster Security that we provide, and then all the runtimes related security that we provide, right? Also with like things like ACS. So you had
mentioned, auditors and security and tooling around controlling containers. There's a newish member of the portfolio around auditing containers, right?
When you say newish member, are you talking about like a feature that we're bringing from OpenShift, or?
Well, we've integrated it into OpenShift, but we had acquired a company and they have a tool that.
Yep.
I am mentioning StackRox, yes, but we don't call it StackRox anymore. We're calling it something else, right?
Right. Red Hat Advanced Cluster Security, right? So for Kubernetes, yeah. So that's our product where we're, it is focused on securing that the workloads that's running on top of Kubernetes, right? So and at cluster scale. So this is with a lot of the technologies that are built in that allows you to secure Kubernetes at scale, and also, of course, run the workloads running on top.
Well, if we could step back for just a minute, there's a lot of things about the way that we're working when we're in this world of containers and Kubernetes and so on that are very different. You had talked about sort of defend the castle, defend the perimeter, and a sort of a presumption almost of that, sort of that physical data center and all that goes with that. Now we're in this very trusted environment where you're relying on artifacts and files and images and all these other things. And it's also very dynamic. One of the premises here is that it's not something that's locked in for 20 years, is that it's something that is going to evolve and improve and change a lot. And I think that's part of the issue. But stepping back even further, open source is sometimes believed to not be secure, but in fact, it is actually the more secure choice because it's transparent. But you touched upon, Lucy, one of the, sort of a fundamental issue there is that, okay, on the one hand, it's open. You can look in and you can see where the vulnerabilities lie, but you have to do one of two things, right? You have to either go and look yourself, or you have to have somebody that you trust to do that. And presumably, we are one of those parties that you can look to trust. Can you talk a little bit about how we approach looking at security things, in terms of basically offloading that effort from the end consumer and making it something that they can trust?
Right. So, as you said, the benefits of the open source, right, obviously are things like you're taking advantage of all that innovation that is donated to the upstream, whether, Kubernetes from Google, all the lessons learned they put there from, including security technologies, right? Also, many of the container security isolation technologies like SC Linux, the C groups, etc. Those are all contributed to the upstream as well. However, you really do need to put security gates in place in terms of using these open source technologies securely. As I mentioned, make sure that if you're not transferring that risk to a vendor to provide enterprise open source, such as ourselves, that you yourselves make sure that those open source packages that you're using are consumed securely, right? Make sure that you're you find out where all those vulnerabilities are, and find out where how all those open source packages that you're using. We also don't just take the upstream Linux and make RHEL, right? We put it through our own software supply chain process. We're very picky about what packages make it into RHEL. We do security scanning on the source code itself. We do things at the compile time. We also have extensive quality engineering, quality assurance testing we do on all of our software. We have a secure way of distributing our packages, and of course, we have our own global product security team, right? So if you are not doing this, you need to have something like this in place when you are also consuming upstream directly, if you or do that yourself.
Right. Well, so I think that's where we fit in, well, in one dimension of how we fit in, because I think for most organizations, the idea of being able to do all of that simply to be able to stand up applications is probably not realistic. And so I think we have a really important role to play there. And part of our role also is participating in important projects that that help improve things like security, particularly when we look into this sort of brave, new, and uncertain world of cloud deployment and some of the new kinds of risks that come in with that are very different from the old, defend the castle world. And so one of those projects that we are involved in, and that I think it shows a lot of promise, is Keylime, and that's how we happen to have Michael and Lily with us today. Is that Keylime is fundamentally about answering the question, how do you secure the platform? How do you get to that level of comfort that you might have with, the old defend the castle procedures and routines and so on, but when you are in this world that it's someone else's castle that you're running your mission critical apps in. And so
right. It's also interesting because that root of trust is being that redefined for the cloud era. How do you think about root of trust differently in the cloud? So that's also what's interesting about this as well.
Right. So with that, Mike, maybe could you tell us what Keylime is? A little bit more than just the hint that I've alluded to here.
Sure. The problem that Keylime is trying to solve, as you were talking about, is how do you secure something when you don't control the underlying hardware? So this is a scenario we see in the cloud, right, where you're running VMs on somebody else's hardware. It also comes up in edge and IoT cases where it may not be running in a VM, but it's running on some hardware that may not be under your physical control. And so Keylime tries to come in there and give you this root of trust when it can hardware-based, when it can't software-based. But it's using something called a TPM. A TPM is a hardware chip, or can be simulated in software, that has a lot of really nice cryptographic properties, such as built-in random number generators, cryptographic hash functions. It can do encryption, seal data. It can store cryptographic keys. Also, one of the cool things about it, they have these registries, kind of like a normal CPU, but specifically for security, that can't be written to, only extended. So when an application is writing to the TPM, they don't overwrite what's there. They instead extend the hash. So the hash of the first value might be in there, and then they add a new value and it gets hashed and added to that other hash. So everything that's measured and stored into this TPM, or what we call extended into the TPM registers, is a sort of a history of every action that's come before it. And this gives some really nice properties that you can do or use for a lot of things like measured boot and remote attestation, which that's Keylime's core focus is on those two things, measured boot and remote attestation.
Well, so what we want to do basically by using the functionality of the TPM in this way is to make sure that at every stage, the state that system is in, the state of the machine. So that's what it's tracking with those hashes.
Okay, so let's unpack a little bit of that. We talked about TPMs, trusted platform modules. There's also something called a TEE. And how are these things different? And when might we care about one versus the other?
So
I can answer that if
on TEEs, yeah.
Sure. So Michael did a good job of explaining what the TPM does. So it has more of a specific functionality. For example, in measured boot, it's very useful, and it gives this property of integrity. So that the system is still in the state that you expect. TEEs are similar in that they have this hardware root of trust, which is important because hardware is basically much more difficult to manipulate than software. You have a lot of different software attacks. We want to have a hardware root of trust for maximum security because it is much more tamper evident. And so the TEE uses this hardware root of trust in a very different way. It is not a specific functionality, it more gives you the ability to have general computation in a secure area of memory on a, I would say, regular CPU. Only some CPUs are manufactured with TEs, but they're generally available now. And so the way that you would use that is, let's say that you have some code you want to run that is very sensitive, or some data that's very sensitive. You can run just that application in this secure area of memory. And that's the property that the TEE gives you. And the keyword there also is confidentiality. It has confidentiality properties, and many of them also have integrity. So what that gives you is that the underlying host system or the hypervisor both will not be able to introspect into your data. It can't read it. That's the confidentiality property. And then with the integrity property, it won't be able to tamper with it. So you get confidentiality and integrity and general computational ability with the TEE, but only for a specific sensitive application. Whereas with this TPM, you are more doing integrity measurement of your entire machine. Does that sound right, Michael?
Yeah, one way I like to think about it is that the TPM helps protect the files on the system and things like your firmware, your kernel, those kinds of things, while a TEE is a runtime protection. So as your programs are running, they can't be altered by the underlying hypervisor or altered by somebody, another program messing with the memory.
Yes.
And so this would be interesting for folks like using hyperscalers, where they know that they're in an environment where the hypervisor is being shared against across multiple organizations, but they don't know who the other tenants are. Is that where we're going?
Yes. So like on AWS, when you spin up an EC2 instance, you can ask it to give you an enclave, and that's what a TEE is a secure enclave. And so they're exposing that TEE to your virtual machine that you can then use. And there's ways to do the attestation against that to make sure that it's the TEE that you think it is, and that nothing has altered that the memory of your runtime system. Now, TPMs are not, like, they're physically more available, I think, than TEEs in general. Like TPMs appear in everything from your phone to your laptop, routers. A lot of TPMs are everywhere, but they aren't as exposed on the cloud system. So it would be nice if next to that checkbox that gives you an enclave when you spin up an EC2 instance, Amazon would also give you a checkbox just like give me access to the TPM as well. They don't do that currently, so in some situations we have to use software emulation for the TPM. So even though you don't get literal hardware root of trust when you're not using a hardware TPM, there are scenarios in the cloud and other places like that where software TPM can still give you some good guarantees about your system.
And a TPM would be useful in situations where you're concerned about the addition of hardware to your machine that may have not come from one of your trusted suppliers. Am I reading that right?
Yes, kind of. In the future, actually, it's interesting to bring that up. Like Microsoft has a patch out currently for the Linux kernel, and the part called the integrity measurement architecture that would do that with the device manager. So when new devices are added or removed, it would cause triggers to the integrity measurement architecture, which then extends those attributes into the TPM, which could be verified by something like Keylime. So that brings me to another point. This Linux integrity measurement architecture, or we call it IMA for short, is a key part of this that Linux has. So it's a part of the kernel that can intercept certain system calls. Like I mentioned, Microsoft trying to extend it to do device management. But currently it does, anytime a file is read, it could potentially be intercepted by IMA and measured. So a common configuration is to have IMA set up to measure every executable that's run by root. And that would be the executable and then the libraries that are linked to that executable. And so IMA, right before those files are accessed, actually measures them, does like a SHA-256 hash on them, stores that internally in the kernel, but also extends that into the TPM. And so those measurements can be validated externally. And that's where Keylime comes in. So Keylime has an agent running on your target systems and then takes these measurement quotes from the TPM and sends them back to Keylime. And because with the security guarantees of the TPM and the key exchanges and lots of things like that happen with Keylime and the chip, we can guarantee that the files are exactly what you want them to be. And if anybody tampers with them, even temporarily, they cannot escape that footprint that's left in the hardware.
So you used a phrase that I think is actually very important for what Keylime brings to the table here, and about this broader issue of securing the platform, and that is remote attestation. Lily or Mike, can you maybe give us a little bit of clarity about what remote attestation refers to, and maybe draw some parallels to an earlier world, what it would be the parallel to, right?
Sure, yeah. So I think a lot of people are familiar with something, what we call an IDS, or an intrusion detection system. So it's a system like AID on Linux. It's an open source system. You set it up to monitor the files on your system, or certain files, and if they get changed without you knowing, it can send alerts about that. So that's sort of the old way of doing it, basically software monitoring software. Remote attestation takes it a step further and puts that hardware root of trust in there. So it's not a separate program monitoring things. It's the Linux kernel itself. When it accesses a file, it measures that file and then records that entry into the TPM. And so each new file that's added gets that new measurement added to the TPM. And so the Keylime agent running on the host can, when the Keylime verifier, we'll talk about the architecture a little bit later, but the Keylime server side basically asks the agent, give me a quote from the TPM about its current state, and give me the list of files and their hashes that the IMA subsystem has accessed so far. And so it sends it back, and with the signatures from the TPM that we can verify this came from this TPM, and then we can walk that list of measurements and validate that we get the same resulting hash at the end that the TPM quote comes back with. So a totally separate system running separately can verify the integrity of that machine, and which is nice, but it gets even cooler when you think about, I can do this across my fleet. I can have a Keylime server monitoring hundreds and thousands of servers, or of other nodes, and protecting their integrity, rather than having just IDSs on each individual one and not having like a centralized view of that. So remote attestation gives you that centralized view of a large cluster, and also that hardware root of trust. So like Lily was saying, like hardware attacks are much harder than software attacks. If somebody rootkits a machine, how can I guarantee that my intrusion detection system is still going to work? Because it's software monitoring software that could be compromised. But they can't do that without physically getting that chip, altering that chip. And when you alter or TPMs are designed so that they're tampered with, they're broken. So it provides some nice security all the way down the stack.
Are there like equivalent solutions in the third-party security vendor space that you've seen, or evolutions that you're seeing already happening in the vendor space? I haven't really seen it, so I'm curious if you guys have.
I haven't seen it really in the vendor space. I mean, that's why Red Hat kind of got into Keylime. Is my colleague Luke Hines was looking around at the vendor space and looking around at open source space and didn't see anything. And this was back in like 2016, so a couple of years ago. But he came across this paper from these MIT researchers that talked about this theoretical way to do this trust in the cloud with TPMs. And then started working with them to build a prototype. Keylime launched as a community project back in 2018. Last year, we became part of the Cloud Natives, the CNCF, the Cloud Native Computing Foundation, as a sandbox project. And yeah, there's not, I don't know of anything equivalent in the commercial space. I do know some other larger companies, Google's, Microsoft's, that are exploring their own attestation solutions internally for their own systems, but nothing that I've seen like that other people can adopt.
One thing I want to say about remote attestation just quickly that is really cool is that it gives people the option, because there is such a chain of trust that's cryptographically verifiable. It gives people the option to actually audit that and check over it themselves if they want to. They don't have to, but it's not necessarily offloaded to a third party. So you're not just moving the problem around. It actually gives you this property where you can check it and verify it.
And so not only are you maybe trusting the third party, but you're also given the option to actually go through and check yourself periodically and make sure that it's actually doing what you were hoping and presuming that it's doing.
Exactly. I think when TPMs first came on the scene, one of their first users was to do what's called trusted boot, which is different than what we call measured boot. So trusted boot basically allowed the vendor lock down the machine or the piece of hardware and not let the user tamper with it or alter it in ways. Whereas measured boot is the opposite. So trusted boot restricts the freedom of the owner of the device. Measured boot increases the freedom because you can control what software runs on there, and you can measure it and verify it yourself. So I think those terms can be a little confusing, and people can conflate them, but measured boot gives the user and the owner of the hardware the freedom and control versus trusted boot, which restricted it from the vendor.
Yeah. If I was to try to restate that, measured boot is really more a concept of visibility and clarity and transparency about what's happening, as opposed to saying, here's a class of things that we're not going to permit to run or to do or to act, right? And so it's really more about, security through visibility and clarity and less about prohibition, right?
Well, I mean, you can have, it doesn't prescribe the policies. You can have policies
Right.
that do prohibit things as part of measured boot, right? If you don't want somebody tampering with your kernel, you can prevent that from happening, right? And that's a good example. But you, as the owner of the system, get to decide what that policy is.
You decide what that is.
Right.
Okay, well, so I think we are going to throw caution to the wind today and undertake a demo, which is always a good way to make a little bit more tangible some of these kinds of concepts that we're talking about. And so, who's going to drive the demo for us today? Is that?
I've drawn the short straw on that. So.
All right. Well, strap in. Let's see how it goes.
So just to get a little visuals on this, the Keylime architecture, we mentioned this before, but we have the Keylime agent running on some untrusted hardware somewhere, talking to a TPM or a virtual TPM. And then over the network, it can be trusted or untrusted, doesn't matter. It talks to the Keylime server side. And the Keylime server side is basically split into two parts, which is the verifier and the registrar. So when the agent comes up, it contacts its registrar to say, hey, I'm ready to go. Here's the details of my TPM. Here's the certificates from my TPM. Let me know what you want me to do. And then after a node is registered, somebody can tell the verifier, okay, these are the details of how I want this machine to be attested. And so then the verifier starts talking with the agent, getting quotes, and then periodic quotes, and it just does this periodic attestation. And then at any point, if it fails, it can do revocation actions. And so in this demo, what we're going to do is we have a setup on AWS where we have a Keylime server with the registrar and the verifier, which is talking to several different web applications. And so it's just a generic web application, doesn't really matter what it is, but it's all running behind a load balancer. And so we have the Keylime agent on each of these web apps talking to a software TPM, because again, AWS doesn't expose hardware TPMs yet, and then getting the quotes periodically to the verifier. And then we're going to fail a node by running some evil script. And then the verifier is going to kick off a revocation action to remove that node from the load balancer. So this is a real world scenario where you have a normal web application behind a load balancer. If any of those nodes gets compromised, you would like to remove it from the load balancer. So this will do this automatically. So let's see if this works. All right, so I have some terminals here, and I'll try to explain what's going on. In the top here, I have the output from the Keylime registrar. So right now, it doesn't do anything until new nodes come on. About bottom left, I have things running the first application. This is the output from the Keylime agent running in that application, and this is the second one. So I'm going to start the Keylime agent here on the third application, and we can see it starting up. And so it talks to the register, gets everything returned, and so now it's just waiting. And so you can see here waiting for revocation messages. So then we can go to this screen. And so at the top here, I have the Keylime verifier running. And so it's checking these two nodes, just continually checking between, these are the EC2 IDs of those nodes in Amazon. And so now I'm going to tell the verifier about this new node, this third node, and what it should do and how it should verify it. And so I do that with this Keylime tenant command. And so I'll walk through these options real quick just so you can understand what's happening. So the Keylime tenant, we're saying that the verifier is at this IP address. The tenant, or the new host that we're monitoring, is at this IP address. This is its ID, which corresponds to its EC2 ID. and which could be anything. Like if it's an EC2, it's EC2 ID. If it's just random hardware, you can use hardware specific keys or IDs on that. Whatever you want. It could be even randomly generated UUIDs. It doesn't really matter. But it's just to track this machine over time. And then we give it an allow list. An allow list is a list of all the files and hashes that we are allowing to run on this system. We can say what we're going to exclude from monitoring, which it's very common to exclude things like log files and anything in a database directory or things like that.
Things that are going to be changing all the time.
Right, that you can't know ahead of time what they're going to be. This is just the CA certificates that are used to communicate with that. This is a payload that's sent over when attestation passes, and this payload will also include the revocation actions. And so we'll look at what all of these look like. So at the top here, this is what a sample allow list looks like. It's basically just a list of hashes and what those files should be. So Etsy password should be this, or anything else. So it's a list of every file and their expected hashes. And then our excludes are here. And so this is a pattern matching, so we can exclude anything. And in fact, see, we have Etsy in our allow list. We have a lot of other things too. The allow list is pretty long, 64,000 entries. But we're just going to ignore everything in Etsy, right? In this scenario, it can change. We're not guaranteeing that something might be pushing out. In a more mature, evolved situation, you might actually want to monitor the files in Etsy and say they can only change after going through our CI/CD pipeline, and our CI/CD pipeline also updates the allow list.
Just out of curiosity, does it calculate allow or exclude first?
So the allow list is definitive. So you can't have something that's not in the allow list, right? Okay. And then if there are things that fail to be in the allow list and don't match the excludes list, those cause problems. So the allow list is the definitive one, and then the exclude list kind of layers on top of it.
Okay.
Excluding stuff in home, and I'm also excluding stuff in this root keylime, which is where I'm running this from source currently. And then we have our revocation actions, and in this case, it's just a Python script that's run by the revocation actions. And in this case, so if the action is a revocation, we're going to run it, and what we're going to do is make a call to the AWS command line. The Elastic load balancers, we're going to deregister a target. This is the group, which is just here. That's our Elastic load balancer group. And the target is whatever agent was just revoked. And so we can see here.
So, Michael, if I can interrupt you for just a second.
Yeah.
So being familiar with AID, it tracks a whole bunch of properties about files. And then the downside is that you actually have to run a check against your database to know that anything has changed. So here we're looking at less metadata about files, just looking at the content, but dynamically monitoring those files so that as soon as the content changes, we can take action, right?
Yes, or yes and no. So in this scenario, I'm showing how to use Keylime to just do the measurements of the file, so the contents of the file, like you said. There's another way to use it, and to use IMA as well, so that you have each file is signed and by a key. So for instance, in upcoming versions of Red Hat, each file that's installed by an RPM through Red Hat, like an official Red Hat file, will also have signatures of that file signed by Red Hat keys. And that signature includes the contents of the file and also the attributes of that file. So so the attributes can also be measured. It's just you get two different things. Like you can use either or with Keylime and IMA, or you can use both together. So they just have different reasons you might want to use one over the other. But you can get both the integrity of just the contents or the contents and the properties of that.
So there are certain, let's call them environments, where maybe the data integrity is one concern, which we solved here, but then also access to that data may also be a supplementary concern. So like if someone was able to get read access on a file that they did not have read access on before, that could be a problem. So do we have a
Right.
way of
So if you're
addressing
using,
concerns like that?
yeah, if you're using the IMA signatures versus the IMA measurements, then the signature when it's signed by the vendor will have, or in this case, like when you're signing the file, and it could be Red Hat specific files, or if you want to do your own files, then that signature would be, you'd have to manage the key and do the signing and all that yourself. But you sign it with the contents of the file and the attributes of that file. So yeah, if somebody changes it from, you know, to give themselves read access when they didn't before, it would then fail that integrity check.
Excellent. Thank you.
Yeah, but I think this is the simpler way to visualize what's happening, is just to look at the file contents. And then, as you can see from here, I have an elastic load balancer, which has these 3 nodes, app2, app3, and app1, that are these 3 nodes that are being monitored. So now let's go back and add. So we added this node, and now waiting on the revocation messages. So now let's do the Keylime tenant command to tell Keylime exactly how to monitor that file. All right, so it's got the quote validated from that new system, and you can see now here the verifier. We were doing, let's see, it was the I058 is now validating the I58 machine. So now I have an evil script in my home directory. I'm going to copy the user
evil.sh.
evil, and then I'm going to run it. And so now we see here, not found. This file was not found in the allow list. Some entries couldn't be validated, and then sending revocation to listening nodes, right? So that triggered the event on this remote attestation system. So I just ran this thing that shouldn't be allowed to run, and now I get this event. So now we come back here, and I've noticed there's a little bit of a lag, but now we can see that the node is draining. So it's been deregistered from the target group in the elastic load balancer. It's draining any connections that were there to it, and now we'll not receive any new requests to that node. And there we go.
And so the thing that, so user bin evil sh was there when we registered the node, and we had the content hash in the allow list. And so when you overrode it and you changed its hash, that's what kicked off Keylime from issuing the revocation.
Well, actually, the script was there from before, but still wasn't in the allow list. What triggered the attestation failure was the script being executed. So because I have IMA set up to only monitor files that are executed by root. But you can have it set up to do lots of different things, to monitor every file that's accessed, that's read or written to, or any file that's executed. And in this case, it was executed as root, and so that's what triggered the attestation failure. And the nice thing is, like, if I go and remove that file and then try to restart attestation, it will fail again, because the history or the trace that file was run is now in that TPM and can't be removed. So even just removing the file won't restart attestation. So I can't like just compromise the system, run a script real quick, and then delete the script and get out. The trace that ran is still there.
So being an operations person, and may or may not have made a mistake 1 or 2 times in my history of doing things. Let's say that I accidentally did something, caused a revocation to occur, and it's not as simple as just reattaching the node, like approving it and reattaching it. How do we do that?
You have to reset the TPM, which in most cases just means rebooting the machine. So you reboot the machine, it goes back through measured boot and gets to a state where it should be, and then you can restart attestation. But yeah, okay. I mean, that something like Keylime, when you don't have a very mature environment or very disciplined environment where any change that goes through has to be automated and go through your pipeline. If it's changing or altering files that are being monitored, you have to create a new allow list to go with that and update Keylime is the same way you're going through it. And then, so if you're manually SSHing into these systems and manually changing files you have to be very careful with something like Keylime, because you probably want to put it more in an advisory state. So the way Keylime does revocation right now, there's different revocation actions it can send to be executed. It can also do, in an upcoming release, we'll have webhook support so that it can call out to a webhook. So when you're first starting out, you might want it to just alert you, send a notification to Slack. This node failed attestation. It needs to be restarted or something like that, so that you can make sure that your process of how you update these machines is very mature, and you don't want to fat figure DOS yourself or running. Yeah. So it does take a lot of discipline, but it's for these very specific cases where you do not control the hardware and you want to control what's running on them.
Yeah, and I think
Right.
Discipline is a great description. Over the years, we've moved from kind of the Gilded Age of system administration, where I lovingly handcrafted 4 systems, and that's what my job was, to, I have to manage hundreds or thousands, which brings that need for greater discipline and not just like SSHing and running commands by hand, because it would be impossible to manage it that way.
Exactly. Yeah.
In fact, it structurally makes that a thing that you probably are not going to want to do, because you're going to bump into exactly the kinds of situations that were described.
Right, and this brings up, I think, leads into another scenario of like, how do you manage these allow lists? Like, how do you craft them? How do you know what software is approved and not? And that's where a vendor like Red Hat comes in. We have future plans to make this an integral part of our systems, to give you pre-approved, pre-signed allow lists from our Red Hat products that you can then incorporate into Keylime or any other system, and that you can combine that with your own allow list that you generate through your CI/CD pipeline. Lots of different ways to do this, but we in a vendor-supported way where we are helping you, solve these management headaches of how do I manage my allow lists.
So, Michael, we did get a question from the chat from one of our YouTube viewers. So we talked about how you can get notified when events happen. What are some of the mechanisms by which those notifications are viewable or available to operators?
Yeah, so there is a very simple web app that comes with Keylime, although it's very simple, but there's REST APIs to all the different pieces of Keylime. So when you're integrating Keylime into something else, because specifically, I think most organizations want a single pane of glass. They don't want something else they want to look into to see what the status of the nodes are. So the REST APIs for the registrar and the verifier can let another system know the status of individual nodes at any time. And these revocation actions can either be, like I said, these Python scripts that are executed either on the nodes themselves. Like if a web app node, one node fails, all the rest of the nodes can execute some script to cordon off that node or in some way. But you can do a lot of like custom actions that way. Like I showed here, we did an elastic load balancer, removing, deregistering a node. You can do like a Kubernetes cordon and drain, where the worker node is actually pulled out and all the work on it is migrated to another node. And with the webhook, you can integrate with things like Slack or other messaging systems, or you can just have a single webhook that sends back the notification, and then you do a whole bunch of chain of stuff with it, however custom you want to do that on your side. So it's pretty flexible in those revocation actions.
Very interesting stuff indeed. So let me just kind of redirect us a little bit out of Keylime, which we'll come back to in a moment. But are there some other projects that are sort of in the same space and trying to accomplish some of the kinds of things that we're trying to accomplish with Keylime? I know there's Sigstore, for example.
Yeah. Well, let me talk a little bit just about I should turn some time over to Lily to talk about the future of Keylime and how.
Okay. Well, yeah. Let's talk about what's coming up in Keylime first.
Yeah.
Because you have a slide.
That'll help us, but it also helps us bridge into what you're talking about, Sigstore and the other supply chain stuff.
Yeah. So we have some exciting future work coming up with Keylime. I can definitely talk about here the first one, the Keylime Rust agent, which is what I've mostly been working on. There is a small team of us to port the agent, which is the the part of Keylime running on the node that's proving its state, over to Rust, which is a safe systems programming language. And Rust is a very cool language, but the important thing here is that this makes it more appropriate for minimal and immutable operating systems. So like cases on the edge or cases like Red Hat CoreOS or Fedora CoreOS, we don't necessarily want to pull a bunch of dependencies in Python into that. So this Rust agent will let us bundle like a self-contained binary and easily like place it in those environments, which will make it more widely accessible. So that's pretty cool. And then Michael, I don't know if you want to comment on some of these other ones. I could read them, but we're moving towards some containerization is kind of the exciting stuff. We were able to run this VTPM, the software TPM, in VMs right now, but we want to definitely also be able to do it in containers. So some of the future work is moving in that direction.
Right. So as the demo showed, yeah, we were monitoring a VM because that's where IMA is focused, like the Linux namespace or Linux IMA subsystem. So it's not namespace, which if you're talking about containers like file system and the network and the PID namespace, all those things are what allow the container to exist kind of separately. So there's work being done to create an IMA namespace that will let containers have their own view of the IMA measurements, and then you could run a Keylime agent inside of there and verify the contents of the containers at runtime. Other things with the runtime of containers with runc VTPMs being allowed, so the container can talk to the TPM, Kubernetes operators, and all kinds of stuff that are in the future for coming up.
All right.
But yeah, talking about
Please, go ahead.
future. Now you mentioned this like Sigstore. Sigstore is an interesting project that's also coming out of our group here at Emerging Technologies in Red Hat, and it allows the software supply chain to publicly sign artifacts in a way that wasn't available before, and not only just publicly sign, but publicly verify from everybody in what's called a transparency log. So this is very similar to the transparency or the certificate transparency project out of Google, which tracks every SSL certificate that's ever issued, and that browsers can then verify and look at certificates as they're issued or revoked. And so it takes those concepts or that idea kind of combined with the let's encrypt idea of democratizing SSL certs. So Sigstore is democratizing artifact signing, essentially. So you can prove the provenance of any artifact you want in your system. And so as we build these into lots of different open source projects, and lots of different open source projects are signing their stuff, all these signatures can then be verified all the way down. And then the integrations with Keylime would be really nice because your allow list could also be a signed artifact where you're pulling your allow list from. For instance, if Red Hat starts publishing allow lists for a certain version of our operating system, then we can publish that allow list in the signature to Sigstore. Keylime can automatically pull it, find out where it is to Sigstore and pull it down, verify it because it's publicly signed in this public transparency log. And you get all these just nice guarantees about your whole system and everything moving through the system. So there's a lot of really cool opportunities there. So here in Emerging Tech, we're looking at like 1 to 2 years out. And this is going to be an exciting space to keep watching for integration.
Well, it sounds like it. There's a lot there. And, just to sort of wrap things up here before we get to our sweet internet points, if somebody's interested in learning more about Keylime, I guess they can go to keylime.dev, and I think we posted that in the chat. But I know that we've actually also got some security workshops coming up. Can anybody tell us a little bit about some of those?
Yeah, so if you go on, I don't know if we put it in the chat, but it's red.ht. Okay, red.ht security workshops. So we have the virtual security workshop coming up in October 21st. And it is focused, it's the various hands-on exercises we have that's focused on OpenShift security and advanced cluster security. So, if you want to look at different use cases, around these technologies, I highly encourage you to sign up. But it's virtual and it's also free to attend.
All right, and we also have a Red Hat Security Symposium that'll be on demand. Anything?
Yeah. So for Security Symposium, it was back in July, but it is on demand, so you can go and listen to all the different sessions we had around container security, Kubernetes security, data security, compliance. We had various different sessions around this, so encourage you to go listen to those as well.
All right. Well,
But there's also coming up at KubeCon, we should have a booth for Keylime and Sigstore as well. So feel free, if you're at KubeCon in person, and there might actually be some virtual Q&A booth times as well. I don't know the details of those, but be on the lookout if you're curious about those and you're attending KubeCon virtually or in person, and come by and say hi to us.
Yeah, good mention. There will be a solid Red Hat presence there, including myself and my colleague Henry Main, to talk about some of the certification things that we do around Kubernetes and OpenShift. And so, with that, thank you very much, all of you, for joining us today. This has been incredibly informative. I feel like my head's about to explode, actually, but it'll pass. I think this is a fascinating subject, and it's also a very fast-moving one. So we might have to have you back to give us an update on where things are in, a matter of 6 months, or maybe, maybe less, because that's how fast things move sometimes. So anyway, thank you again. It is that time now for us to talk about sweet internet points, and we actually have a bit of drama this week. Scott, look what we got. Narendale,
I mean,
who seemed, unbeatable, basically.
Yeah. So all those people out there, they're like, oh, I'm not going to bother, because why? There's so many points that I don't have. Clearly, if you just keep going, you'll get on the leaderboard eventually. Right.
So keep coming. Keep collecting the sweet internet points. You do that by going to one of the URLs here in the bottom of this slide, which we will also post to the chat. Enter your code, collect your points. Remember, Narendev looked, beyond reach, and yet now neck and neck with NLH ACM. So collect your sweet internet points, and keep watching. And again, please like, subscribe, and share. And thank you, everyone, for joining the Level Up Hour this week.